Hello everyone, welcome to Coding Made Easy. Today we are going to discuss the problem validate binary search tree. So given the root of a binary tree, determine if it's a valid binary search tree. A binary search tree is valid if the left subtree of a node contains only nodes which are less than the root and if all the nodes in the right subtree are greater than root. Say for example, left of 5 is 1, right of 5 is 4, 3, 6. That is 4, 3, 6 are greater than, no, they are not greater than 5. So 4 is not greater than 5, 3 is not greater than 5. That's why it's false. So let's go here. So 1 is less than 5, 7, 6, 9 is greater than 5. So for 5, the BST rule is applied and is working. So for example, let's take 7. Left is 6, smaller than 7, and right is 9, greater than 7. So for every single node, for all the nodes in its left subtree should be smaller, and all the nodes in the right subtree should be larger. So how can we find that? So let's look at this problem in a slightly different point of view. So the requirement is if the node is 5, the root can be anything. What is the range of values allowed for root? It's minus infinity to infinity. So any value can be there. So all the nodes in the left subtree of 5, their range is, the lower range remains minus infinity, but upper range remains 5. So this square bracket means you're excluding 5. That is the problem statement. So what about right side? The smallest possible value allowed is something greater than 5, and the largest remains infinity. And what about here? The smallest value allowed is still 5, but since we are in the left subtree of 7, the largest allowed is something smaller than 7. So here it is. Suppose if there was another node, what is the value of range allowed for the value of that? Minus infinity to 1. So this can be 0. So that is all. So if we move left, we just update the upper range allowed value to the node value, and if we move right, we change the uh, lower limit. So let's go to the code. So let's create a wrapper function. So min and max are the ranges we are going to pass, and root is the node. Good. Min less than root max. So if the root dot value is in between this range, we are good. Then so note that the left minimum value did not change when we go to left. So when we went from 5 to 1, the minus infinity did not change. But the upper range changed to the root. So that is why upper range is remaining that way. So and of those two. If left subtree is good and right subtree is good, then we are returning true. So this return false is if we don't get into this if, that means the node itself is not following the BST criteria. So here we would just call so this is a Pythonic way of calling the negative infinity. So test cases have passed. Submission is accepted. What is the time complexity and space complexity for this? Time complexity, we iterate each node once and only once, and space complexity is also big of n because there is potential to store n elements in the recursion stack if we have a single path tree like this. Then we keep on going, and since we are doing depth first search, we'll keep on adding all these nodes into the stack trace, causing the space complexity also to go to big of n. Thank you everyone. Catch you up in the next video. Bye.